in that case, we calculated at the very first step is the tau maximum equal to C, I forgot C1 or C2, and AB squared. I think, let me dig up, let me put into my, I don't want to, okay, A is a short one, B is a long one. So that should be A squared. Right? No, B is a short one. B is a short one, A is a long one. So this is AB squared. Okay, and then we have the angle of the twist, and that one. TLC2 GABQ. So this is the first method we introduced. Okay, kind of give you summaries, and we can have done some reflection.
Is it 1 or T over C1?
T over C1. T over C1.
No,
and
C1
C1
had it 1 over
1 on top.
Oh, thank you. And C1, C2 are from the tables. The second one we study is the thin wall. The thin wall in general, that can be a varying thickness, okay? And the most important thing is in the thin wall, we assume the constant tau across the thickness. And you know that this assumption is not so accurate for thick one. For thin wall, that works fine, just fine. So that means here we emphasize this is for the thin wall structure. That means the T, although can be varying, but shouldn't be too thick. Otherwise, we have to come up with a thick wall. They do have a thick wall tube theory, okay? And that one takes non-neutral. So this one is what we have. Okay, so that is go to the formula. And then the third one we've been studying is the multi-cell sections. So basically here that is the one step further from the thin wall structures. Okay, so for this case, everything is based upon the thin wall series, and then but we're taking care of the shear flow in each cell. So the thinking process for the multiple cell is we decompose the problems into every single cell. For example, this one we call the cell 1. For cell 1, we apply the fundamental properties for cell 1, and then for cell 2. The same thing, etc. Okay. And so far we have done is this, and since so far so good, those formulas, those thinking process will be sufficient to help us solving many kinds of the general the shaft under torsion, and the. Anything else? The question right now I'm asking you is anything else we couldn't solve? Any other shaft? I mean, the shaft with any other sections we couldn't solve using our formula.
Triangles?
Triangles. We can let me write it, and then we can justify. So for the triangle, for example, like this, pretty much this one will be in topology is similar to this one. So that should be okay to apply this theory.
What about a solid triangle?
Solid triangle, yes. For this one, since we don't have, right? So we only have for the rectangles. We don't have this one. Okay, so that's the first one. And anything more?
Concave shape.
Concave. For example, say if this is a circular and then, oh, apple. So concave one like this, if there's a solid shaft but there's a concave, yes, we don't have the good tools. Okay, so this could be the second one. Anything else?
Non-rectangular solids.
Non-rectangular solid. Okay, so basically that's belonging to this one. So the third one is more generic, like this one. Okay, that's pretty much, I think pretty much there, right? The last approach, that is more qualitative, and that's a new section. Okay, this one, let me open up the file.